already seen what's coming.
Hi.
Hi. Welcome to the FOSDEM 2020 Distribution Discovery. Our next talk is going to be on Fedora package, rawhide package gating with Pierre Yushiel.
So, this being the last talk of the last day of FOSDEM, I'm very thankful for everyone to be present in the room. So we're going to be speaking about a special version of Fedora, which is the rawhide branch, and how we've implemented gating packages in this version of Fedora. I'm not going to go to the mechanisms of what we gate on. The idea is not to go into which tests are used to make a decision about whether a package should go through or not, but I'm going to run through the mechanism that reflects the infrastructure, the architecture, and the mechanisms that we have to put in place to be able to gate in general. The question on which tests are used to gate, or we can discuss about that, but actually not discuss in the slides here. So what am I doing today? I'll start with quickly going through a glossary, because I know some familiar faces in the room, but I also see some unfamiliar faces, so I don't know how much of the Fedora ecosystem you know or don't. So I'd like to leverage a little bit, make sure that we're speaking about some terms. Then we'll go into why we want to gate rawhide, what's the benefit there. Some of it's the challenges that we have had to face, or some of the constraints or requirements for the project. Where it's at now, what's the status of things? How you can debug, try to see if you can unlock yourself if you run into some of the corner cases. Ideally, I don't want to point to this is a great presentation, everything's working, great. So there shouldn't be a debugging slide, but things happen, some bugs exist, so there is a debugging slide. Then I'll go explore the roadmap on what, once we have this in place, where we want to go, where do we want to go. And then we'll finish by a small surprise for the regular Project 1 that's staying to the end. Alright, that's going to be confusing. The laptop's not showing what's okay. So, what is rawhide? Rawhide is basically the development version of Fedora. It's a rolling release, it's a rolling distro. There's never a release of it. It's composed every day, but you can find it on Mirror, but there's not a version number of it. It's present every day. It has new packages coming in, and everything in Fedora lands in rawhide before it lands to single release. Then we have how does the packager workflow works. It starts in what we call dist-git, and dist-git is basically a term that we use for two things. It's a collection of Git repositories. Every single package in Fedora has the corresponding Git repositories in which the packager are maintaining spec file and the patches. Question?
It's also like a web service and Git hosting platform by Fedora and Web.
So is this Git also a Git hosting platform?
It's kind of a platform, big, huge repo, host of repos, and it's not exactly Git, it has some limitations.
There are plain Git repos. What sits on the top of it is a web interface that we have designed to sit on the top of it. But the core infrastructure is basically two elements. It's a basic Git server and what we call the look-aside cache, where the packager uploads the tarballs from the upstream projects. So it's really a collection of Git repos, not a central one. And each one is different, but it's plain Git underneath it.
Some limitations can go after.
Sure. There are some limitations, but you can't force push, for example, if that's what you're thinking about. But these are configurations that you can do to any Git repository. It's not specific to our deployment there. Then we have so once you have your Git repo, your Git repo, you have your specs patches, you have the sources from upstream, and Fedora uses a build system. So everything that is shipped in Fedora is built in a control environment, which is called, in our case, Koji. So that's where everything is built, and builds are managed with tags. So a build in a certain tag is in a certain state. If you reach a certain, if it moves to the next tag, it's moved to the next state. So basically, the tags will give you a little bit of the state of the package. If it's in the F32 tag, that means it's available in the build root for rawhide at the moment, which is still F32. Something that we're going to come back with is they are called side tags. They are basically tags which are sitting on next to the usual main ones, and they are used to be able to do work without impacting the main tags. So they are isolated from the other, but they rely on the base tag. So there is a hierarchy between the tags. So you have the base tag, and then the other one sits on the top of it. So the lower down, you can always access to tags which are underneath you, but you can't access to tags which are above you. Then we have our update system. Once we have made a build, we can say, well, I want this build to go up to the users. This is handled by an application called Body, and basically every packager gets to choose, well, that application goes to the user, that update does not go to the users. That is true for every stable Fedora releases. That is not true for rawhide. In rawhide, as soon as you build something, it's going to go to rawhide. So there may be builds which are wasted, there may be builds that would not need to go to the users, but the mechanism of rawhide has always been, if you build it, it goes to rawhide. In stable releases, you can build it and say, well, actually, no, I don't want to push this one. One of the aspects there as well is also, if I push something, and then I realize it's broken, I can then push it up to a certain point, so it does not affect our users until we are kind of sure that it won't affect. We have an MQP-based message bus called Fedora Messaging. Well, Fedora Messaging is basically a wrapper around MQP to make it easy to send message on the bus. This is very used for making the different applications talk to each other. So Body will listen to messages from Koji. Koji may react to messages from another source, and so on. And finally, we have something called the robot signatory. It listens to the messages coming from the bus, coming from actually from Koji, and it will, so every time there is a build, it will be notified of it, get the RPM, sign the RPM, and move the build to the next tag in Koji. So why do we want to gate rawhide? Well, simply, rawhide is a place which is, I think that's true, fairly well known in the Fedora community to be something which is not stable. I don't think that's wrong to say that. It is wrong, however, to accept this. There is no reason why rawhide should not be stable. The only reason why we allow rawhide to not be stable is because we don't have ways of grouping changes. So if I build something and it dumps the surname, then I need to rebuild all the dependencies, but that can take me some time. And during the time that I'm rebuilding all the dependencies, well, rawhide is broken. That leads to situations like F29, I believe, or F30 when we branch. So we branch off rawhide to make the stable releases. When we branched off rawhide for F29 or F30, I forgot, we did not have a working compose for about a month because rawhide was broken. When we branch off rawhide, we branch a broken Fedora. So there is no reason why we want to keep rawhide broken. And gating is about preventing this breakage from happening. So we want a more stable rawhide. With more stable rawhide, we'll get working composes. This means when we branch off rawhide, we'll get a working compose, we'll get a working F32 for the F31, F32 for the next one. And we can already work on that project. That also means faster updates for rawhide itself, because in rawhide, updates, the push of the updates of the rawhide updates to mirrors happen as part of the compose. If you don't have a compose for a month, you're not pushing rawhide update out to the mirror for a month. So everybody using rawhide is not going to get their new versions.
Can you be more specific about what compose means in this context?
So the compose is, so the question is, can we define more precisely what compose is? That's an overloaded term which is always very hard to define. The basic answer is, when we compose Fedora, we are rebuilding the update repositories, the DNF repositories that we are pushing out to our mirrors. But we also are building our ISO image, for example, our base image for containers and so on. So depending on who you talk to, you may be talking about a part of the process or the entire process. But yeah, when we talk about a rawhide compose, it means generating the repo, making sure the repos solve themselves, so the dependency resolution works, building the basic images. And if one of these steps breaks, the entire compose is considered a failure and not pushed to the users. Well, and one of the last things why we want to gate rawhide is we want to get in the point of well, some of us have the chance to be paid by companies to work in Fedora.
the vast majority of the contributors in Fedora are volunteers. They do that on their free time, which is a great investment. We can't thank them enough for using your free time to come and help us and work on Fedora. It's awesome to have you there. I've been there, before I got the chance to be hired to work on this. The only thing is, you may be maintaining a package, and then something lower on the stack breaks. And they can't rebuild it because for X and Y reasons, they don't have the permissions to do that. And then suddenly, what you're doing is you're on holiday. You're having family time. You're working on something else on your pet project. And then you get an email saying that your package can no longer install because there is a FOSDEM bump in one of the dependencies, and you have to go and fix it. You have to go and rebuild your package because someone else bumped a FOSDEM and did not warn you, and you couldn't coordinate the change with that person. So we want to get into the mood of you break it, you fix it. It's fine to break something. You just don't. You fix it, and when you push something out, it's something which is fixed. It's something which is working. So that's one of the challenges that we want to bring to rawhide. It's not okay to have rawhide broken. It is okay to break things, but let's break them in a way that does not impact everyone but you until you have figured a way to fix them. So what are the challenges? Well, the first challenge was to make it happen. It's not the first time, if you're part of the Fedora community, you may have heard it some months ago, I would say. It's not the first time that we tried to work on this, but it failed for a number of reasons last time. So when we start to look into that again, we need to be careful on why did it not work last time, and how can we make it work this time. The second one is, well, those are more requirements. We want to fit into the existing tooling. We don't want to reinvent a build system that will provide us the gating. We don't want to reinvent an update management system. I'll come back to this. And we want to interrupt the packager workflow as little as possible. Every time we change something in the packager workflow, we are imposing something on our community of contributors. And if you update a package every day, that is, you quickly learn the trick to use the new way. If you're packaging something every 3 months, every time you have to go back at the documentation and where is it again? And is that page of documentation up to date, or is it this one over there, or is that this email which I'm finding in my mailbox somehow? And then the last one is, well, there will be bugs. There will be bugs in the CI, there will be bugs in the test, there will be bugs in the way we test things. So we need to have a way to handle false negative. So something which works, but is identified as not working. So we need a way to bypass the result of the test in a way that is satisfactory for our packagers. So having all of this in mind, one of the ideas was that we would roll out the changes in phases. So we try to do the easy one first. So the easy one is it's an update that only contains a single package. It's only, it's a Python module that is updated, that does not depend on anything. It's pure Python, it's Python 3, it's the most simplest thing you can think of. This is the easy case. One build, one package, one update. And then as we get user feedback, as we polish them, we also work on to how do we deal with updates that contain multiple builds that needs to be shipped and tested as one unit. So this was our idea. Let's do single build first, let's do multi-build after that. Gather feedback as early as possible and try to account for that feedback as much as we can, and try to get a polished user experiment at the end of it. Where is it today? Well, we've announced at Flock, so the Fedora conference last summer, that we were able to do single package getting, and I'm now happy to announce you that we can do multi-package getting as well in Fedora. So how does it work? These are slides which are back from I just went back to the slides which I used at Flock when I presented this. So for the single build getting, it's a fairly complex system. This is basically the flow of everything. It's not meant to be read, so don't worry that you can't read it. It's just to give you an idea. Every column here is a different system, and then every box is a different action. The user being the first system over there. And as you can see, the interaction with the user are actually fairly limited. There is only the packager starts a process, and there is the override here, which is basically if something goes wrong, handling the false negative case here.
Do you have any steps where there's a human who has to present some input or approve?
No, everything is automated. So this is the simplified version of the large graph, which is much easier to grasp, and even for myself, that's the one I go back to when I need to see if something is working the way it should. We have a packager. That person does a Koji build in a certain tag in Koji. So this is this is a candidate for an update of the F31 that was made this summer before F31 was out, so F31 was rawhide at that time. Koji announces that he has built and tagged the build into this tag. Robust signatory receives the message, signs the build, and pushes it into update pending. Buddy gets a message that an update was pushed into update pending. It creates an update, and then it waits. When it creates the update, it sends a message to the CI system that says, this update is ready to be tested. The CI system is going to test it. It's going to come back to Buddy and say, yep, that can go, and Buddy moves it. Or the CI system says, no, that can't go, and Buddy says, well, I can't do anything there. So one of the changes that we have introduced here is that Buddy was not part of the question before. Before you would build, it would be signed and pushed directly to the stable type, to the build root. Nowadays, everything goes via Buddy, because Buddy was the place which was natural for packager to get feedback about an update. So we have fit into the existing workflow. We changed the workflow because we introduced it, but it is a natural place for packager to receive feedback about if something is going right or not. Why is it a natural place? Because Buddy, when you create an update, Buddy is the place where people can report if an update is working or not. So there is already a mechanism there for comments from contributors in the community to say, well, that update broke my system, let's unpush it. So this is the idea. Now, multi-builds. Well, the picture didn't get clearer. The number of systems did not get smaller, and the number of interaction actually didn't get that worse either. So the simplified version again. You start by creating a site tag. So this is a manual step. So that changes from the way you were working before. You create a site tag, and that is your site tag. It's F32 is going to be the base. So currently F32 is right, so that's going to be always F32 site, and then a random integer. Well, it's an increasing integer, not a random one. Then you're just going to build in that site tag as many packages as you like. If you have 2 packages, you do 2. If you have 100, you do 100. Once you are ready, you're going to be the one going to Buddy, and you're going to tell to Buddy, that site tag here is ready. Buddy is going to get all the builds that you've made in that site tag and turn it into a single update. It's going to signal that to the CI system that will kick off the. So it's going to create the updates. It's going to move. It's going to Buddy at the time when you create the update, it's creating 2 site tags as well. It's using the same ID, signing pending, and then testing pending. And once you have created this 2 site tag, it moves all the builds from your site tag into the signing pending. Robust signatory has pattern matching algorithms that says, well, everything that is F32 side something signing pending, I'm listening to. I take all the builds in the updates, I sign them, and I move them to the testing pending. Buddy gets the notification that something was moved to testing pending. It marks the update as ready to be tested. It signals it to the CI system that will perform all the tests on all the packages at once. So if you have 2 packages that need to be tested together, it will make sure that both packages are present on the system to be before the tests are run.
Who is the actor in this case?
Sorry?
Who is the actor?
The actor there is the packager.
Packager maintainer?
Yeah.
Is it like internal Red Hat employee or outsider?
Anybody in the Fedora community who is a packager can do these steps.
How can we create the tags?
Fed package request site tag. So Fed package, the question is how do we create the site tags? There is a utility in Fedora that's used by packager that's called Fed package. It's a small CLI tool, and there is a simple action that says Fed package request site tags that basically goes to Koji and asks for a site tag to be created, and it returns you with the ID of the site tag, which you can then pass on to your build command, and that you specify to Buddy afterwards. The nice thing is that a site tag can also be shared. If you're working on an update with a group of persons, the first one creates the site tags, gives the site tag ID to the rest of the group, and everybody can build in that site tag. And then once everything is ready, someone goes to body and creates the corresponding update.
So if you're building a site tag and you have packages that are depending on each other, so you have with package A and then with package B, so you have the package A, will it take the site tag that goes from package A?
So the question is, if we have packages depending on each other in the site tags, how do we handle package A being present in the build route when we build package B? So there are two ways to do that. The hard way is to do package A, and then you wait for Koji to create the repository for the site tag before you trigger the build for package B. Or you have a nicer way to do that. It's a fpackage command again that's called chain build, and that basically does that for you. It tells Koji, I want to build all of these packages, and they depend on each other. And you can group them, so you can parallelize, say, package A and B can be built together, but C needs package A and B.
Is it allowed to build the same package twice, for example, for a bootstrap build?
The question is, can we build the same package twice? Koji has a requirement that's on the NEVRA, so that's name, epoch, version, release architecture of a package. So as long as you can send to Koji, a Git hash basically to build. As long as the NVR, you can send it multiple times, but if the NVR has already been built, Koji will say, well, that has already been built. I guess the answer behind that is, can I have a build that's present in multiple tags at the same time? Because you would like to send an NVR to that build, to this site tag, as well as the same NVR to another site tag. Is that what you had in mind?
No. I think of the case where I have a package, and another I need to build without its test disabled, and then build another package that depends on this one, and then I want to do a full build of the first package with test enabled or some feature enabled. Yeah. So I'm fine with bumping the release in between.
Yeah. So in this case, it's a bootstrap case where you start with the test disabled, build the dependency, and then build again the first package with the test enabled. So that's because it needed package B to be able to run the full test run. Yeah, in these solutions, you have no choice at the moment but bumping the release again.
Okay. So a follow-up question. Can I untag a package from the...
The question is...
It's technically possible, but does the policy allow this?
So the question is, can I tag and untie packages? And yes, you can tag and untie packages. If you're not allowed to do that, Koji will tell you you're not allowed to do that. But it's one of the elements on how can you unblock yourself if you find yourself that somehow your build lost a tag. You can actually just do Koji tag the tag and the package name, and Koji will happily tag it for you. If you're allowed to do it. If you're not allowed, he will just say, well, I can't do that. So that's one way you can unstuck yourself.
I was just wondering how much freedom do passengers have over Koji? Like, can someone create freestyle target and define their own tagging structure?
So the question is, how much freedom do packagers have to configure Koji? And the answer to this one is none. This is a release engineering task, basically. They are the one that will be defining the tags, the hierarchy. You can create your site tag based on the existing ones, but you're not going to be able to create, official tags on your own.
Okay, that's great.
Will it be possible to start the CI before the signing, or do you need to sign the package?
So the question is, is it possible to start the CI process, so earlier in the process, before the signing? That was one of the questions we originally considered, and the issue which I had with that is that if you end up installing a package, you end up testing the installation of that package, not in the way the user are going to use it. So if something goes wrong here and the package is not correctly signed, suddenly my test install is going to fail because the package is expecting to be signed, because in Fedora by default the DNF configured, the DNF configuration requires the package to be signed. So this is going to fail. If you say, well, I'm triggering from here, or directly from the Koji build, well, suddenly it means you have to test with GPG no check, which basically is different than what the user would be. So it was a conscious decision to start the CI so late in the process, but in a way that we make sure that what we test is actually what we are going to push to the users.
So how much time, is it a bottleneck, the robot signatory, or?
The question is robot signatory a bottleneck? Yes and no. On a daily basis, no, because the amount of builds that we get is low enough that robot signatory just takes them. It can be a bottleneck during master builds. Master builds is when we take all the 20,000 Git repos of packages in Fedora and we say, Koji, please rebuild. So within a day or two, Koji gets to rebuild 20,000 packages, which means robot signatory gets to sign 20,000 packages. And if we mess up a little bit, which has happened not in this master build, but the last one, where we forgot to turn on robot signatory from the start, we basically had to have some robot signatory go through all the 20,000 builds and, well, copy them over. Are you signed? No, you're not. Okay, I'm signing you. Are you signed? Yes, you are. Okay, next one. Are you signed? Yes. Are you signed? Yes. And that basically swamped robot signatory. But that was a mistake on our side in a way that we forgot to turn on robot signatory early enough in the process. If in the case of the current master build that just happened, robot signatory was set up correctly from the start. And basically, as the build was up and robot signatory was running, so and we didn't get the issue of swamping robot signatory, which we had at the last master build.
Does nobody has any notion about the multi-build updates? Or there is an update for each package? There is for body-wise, there is an update for the whole group of packages, or it's separately?
No. So in the case of yeah, in the question is there an update for every build, or is it a different update? In the case of single build, it's one update per build. In the case of multi-build, it's one update per site tag. So all the builds in the site tags are going to go into one single update. They are going to be tested as a single update. They are going to be pushed to the mirror as a single update.
So the maintainer has to sign some body to say, okay, I've done all my builds. Now you can start.
Yeah, that's one change in the packager workflow. You need to, before you had to build, and that's all you had to do. Now, if you have multiple builds, you need to create the site tags, then do your build. And once you're done with it, you say, okay, you can go ahead. There was thought about automating this and saying, well, we just keep on testing whatever is in the site tags until it passes, and then as soon as it passes, we merge it. But there is no guarantee that there is not some builds left over behind that should be still included in that unit of change.
As a packager, can you create just any site tag? Like, can you get any combination of other packages that are being maintained, put in a site tag, and then can you block CI for other projects just by adding them into your site tag? So if you're a packager,
yeah,
you can create an arbitrary site tag, right?
No.
No, you can't.
So the question is, can I create arbitrary site tags? You can create site tags from a very specific. You can't create a site tag from anything. You have to create a site tag from one of the existing tags and a limited set of the existing site tags.
Right, but if you have like arbitrary packages that are Fedora that you think that are belong together, but maybe web maintainers don't think so. So how is this settled somehow?
So how can we add? What happens if in the case where I'm adding a packages in the site tag which maintainer may disagree with? Well, we are coming back to the NVR question. To build something in Fedora, you need to change the spec file. To change the spec file, you need to have the right to change the spec file, and not everybody is going to have the permission to change every spec file there. So the chances are that you're going to include that you have the permissions to build, that you have the permission to change the spec file to do the build, then end up in your site tags, I'm going to say would be pretty low, because you normally have permissions to the packages you should be concerned about, or that you're maintaining, and that's your own set of packages. And if you are one of the few people that have access to everything, then we expect you to know better than to mess around just for the fun of it. So there is one change between what I've presented at Flock and what is currently in action. So what you see with the multi-build is that we have the user. It builds, it goes to body, and then to a signatory. If you remember what before, and if I'm clicking in the right direction, that will be easier. we had it built, it's signed, and then it ends up in body. And I was basically creating two workflows, depending if you were considering a single build or multi-builds. So we changed the workflow for single build a little bit. Now when you build, it first goes to body. So you already have your update. That update is being signed, and then it's being tested. So we have a much more similar workflow between the multi-build and the single build. One of the advantages here is that basically, as soon as it's built, you have a body update. That body update is in the pending state. With whatever, if you have a single build or a multi-build, you'll have an update in pending state. Once it's signed, you have it in testing state, and once it's out, you have it in stable. So it's just to make sure that we have something coherent between the two workflows. That's just a little bit on going through how the decision frameworks works. So we have, as I was saying, we have body that starts in update, and basically, body basically triggers the CI system by saying that update is ready to be tested. The CI system will run all the tests it finds, and it will send the results to something which is called nicely results.db. So it's basically just a database with an API on the front of it that just stores whatever we churn into it. It's a key store database. You can just put anything in there. It's backed up by Spoiled, but it's basically a key value store. You can put anything in there. Every time there is a new result, it's going to announce it. I have a new result, I have a new result, I have a new result. Then we have Greenwave here, which is our decision engine. It's basically has a set of rules, and it says, well, every time I'm seeing a new result, I'm going to check, well, can I make a decision now? This package has been tested. I have a new result about this package. Can I make a decision? What are the rules applying to this package? No, I'm still missing a test. I'm not going to do anything. Hey, a new result's coming. Hey, that result failed. All right, then I already know that this result was a requirement, so I can announce that this update is not going through because that build has failed. So this is what happened. CI sends the result to results.db, that's StoreTem. Greenwave gets the result from results.db and makes a decision based on these results and sends that decision back to body. If the user disagrees with them because, hey, bugs are bugs, networks are networks, and computers sometimes fails us, surprisingly, the user can override that. And overriding this is basically throwing a waiver. So you send a waiver that says, this result that you find in results.db, you ignore it. You can also say, these results that you don't find in results.db, you ignore them. So if something is stuck, if something is broken, the CI system just simply doesn't work anymore, well, you're not storing any results. So your update is blocked because something is broken and just doesn't move along. So you can say, well, you know what, just ignore everything that's not present, and then Greenwave is going to be notified about the new waiver. It's going to say, can I change my decision? Should I change my decision? And if it does, it notifies body that will react based on that. So that's a little bit the framework. I was supposed to mention this slide because if you're into results.db, results.db, Greenwave, and WaiverDB, these are the trio that's used for actually making a decision about getting or not. So how can we debug ourselves? Well, as I was saying, one of the quick ways to check the Koji tags. So you run Koji build info, you put the NVR of your build there, you have a line that says tag, and then you just look into that. If it's a single build and it's in update testing, well, it hasn't been picked up by body. Something is wrong with body. If it's a side tag, then that's for multi-builds. Then it's still a body problem. If it's in sign-in pending, then there is something wrong with RoboSignatory. It could be that RoboSignatory is just going through the master build and it's just very busy and it's just, it hasn't caught up with your build yet. Or it could be that RoboSignatory somehow broke the connection with the signing server and needs to have a gentle poke restart. If it's in testing pending, well, it's waiting for the CI system. It could be that the CI system is processing a lot of requests, or it could be that the CI system is done for maintenance or for something else. So, if you're there, it's probably something if you're in one of these two here, it's probably an infra issue. If you stay there too long, that's definitely an infra issue. If you stay there too long, it could be RoboSignatory swamp, or it needs a restart. If you're there, it's less a CI, it's less an infra issue and more potentially more a CI problem or a CI system problem. Another way to look into that is to look at the state of your body update. If it's pending, it's not signed. So pending means we have moved we've seen the build in update candidates, we've created the update as pending, and we are waiting for it to be signed. If it's in testing, then the tests are running, or the package is gated. And if it's stable, then you're not debugging anymore. It's working, or it should be working. So some of the user feedback we collected over the last months was first of all the introducing body as an element of the rawhide workflow. Introduce a lot of email notifications. Basically, a single build will give you between 5 and 7 emails. You get one for your update has been created, your event has been pushed, your event has been tested, your update is being pushed to stable. Yeah, okay. Rawhide used to send you no emails. It's now sending you 5 per update. That's a little bit too much. We reduced it to 3. It basically tells you your update has been created. If the test results failed, it will notify you. If they pass, it won't. And your update has been pushed. That's basically the only 3 that you should get. If it's still too much, we're happy to revisit. This is how the middle ground we found for now. If people complain too loudly, we are happy to revisit and see which of these emails are actually useful and which are actually not that useful. When we introduce multi-build gating, if you're a Fedora packager, you may have seen the new UI introduced with Body 5.0. You didn't see the mechanism underneath it for multi-gating because we haven't announced it at that time. But there were some changes there, like the list of builds used to be either space delimited or comma delimited, and we removed the support for comma, which made the code just a lot more complex for little gain. So now list of builds should be only space delimited. There is a mechanism that goes to create all of your builds in Koji, as the builds you've made in Koji. And the mechanism was such that it would basically block the input field while it was loading the builds from Koji. And it turns out that request to Koji is sometimes very slow, or that you have hundreds of packages or hundreds of builds that you've made. And so you couldn't copy and paste. So that was a feature that we thought was good, and that we were told, no, that's not good. So like the GNOME folks who update 100 packages at once, they are actually tracking the NVR in the text file, and then they just copy paste in the field, and they couldn't do that before. So we've reverted that change. You can now easily copy paste your NVR as you did before. And yeah, that's the next point here. The logic that goes and queries body to know which which builds you've made is still a little bit slow, and we still need to look at the performance there. We also had someone that came to us and asked us, well, there is no point in allowing people to comment on an update once it's pushed to stable. And I've had that happening to a few of my updates, and it's annoying, so please disable comments once an update is pushed to stable. And we've had Adam W. coming back to us and saying, no! Because turns out the update is still a mechanism where we can point people, well, that update broke this and this, the Bugzilla ticket is over there. So as a user, if you run into a body update, it may actually be useful to still be able to comment on it, even though the update has been pushed to stable. So that got reverted as well. If you have more feedback, I'm more than happy to take it with me, and I'm sure we'll work through either finding a way to make it work for you or just fixing the whole damn thing. Okay, so where do we want to go from that? Well, we now have mechanisms to gate something. We still need to optimize testing and reporting of test results for groups. So if I have currently, if I have 100 builds, I'm going to create GreenWave for give me the status about that build, give me the status about this build, give me the status about this build. So that's a little bit inefficient when we can tell when GreenWave, when the CI system knows that it's been tested these 100 packages, and could just say as once, well, this group of packages that I have tested, they failed CI. That would be one request to GreenWave. That would be one way to optimize things nicely. So this is something which is in progress, and hopefully we'll end soon. Then we still need to work on now I'm going back to what I said would not be part of the topic, but it is now. What do we want to gate on? So what are our tests? Currently, the tests are defined in the package repository, and they are defined by anyone, basically. Anyone can go there, and there is a specification that the test should follow. They are using Ansible, and you can basically write your own test. This is great, except that having 20,000 2,000 packages writing 20,000 tests for all packages and making sure that, we all want to test whether we can install or update or remove a package. There is no need to have 2,000 people do that for 20,000 repos. We could do that for the entire distro in one go, and that's one test to maintain instead of having a different YAML from Ansible doing the same test for every single package. So we want to look into distro-level testing. Some of them are reverse dependency testing, being able to run the test of the package that depends on me, being able to install, to upgrade, to downgrade, to remove, and we also want to look at the impact on composes. Does your update break compose? Can I push a new rawhide update if your build goes in there? So we don't know yet how we're going to achieve this one, but that is one of the things we would like to go to. Something else that we are looking into is we have the agreement from the FESCO, so the technical steering committee in Fedora, the engineering steering committee in Fedora. So we have introduced 3 test packages. So there are spec files which only ship a UUID in a certain file, and just you can install them. They won't do you any harm, but on the other side, you really shouldn't install them because they're no use at all. But they're useful for us because basically, while working on this, we wrote scripts to be able to make sure things were working. And since we are touching so many systems, it's easy to lose one in the stuff. So the idea is to have this script run on a regular basis, once a day, twice a day, every 2 hours, something like this, and check, is everything fine? Is everything fine? Are the tests running? Are the tests failing? Can I waive the test? Is my update going through? And then, so for a single package as well as for an update of 2 builds, so 2 single builds, multi-builds. So those are the things that we are currently working on. So that will come out soon. Soon, I guess. And one of the discussion there was on the dev list recently about the infrastructure is not reliable. Well, using this, we may be able to look into how often things break in the entire workflow, not a single application, but the entire workflow. How often does the workflow break because one application breaks? It may be a different application at the time, but the result is, as a packager, my workflow does not work. So we may be able to measure how often things break and how often they don't. And that would also help us, when we roll out a new version of Buddy or a new version of Koji, making sure that what we want, these are best scenario. We don't test every single edge case, but we want to make sure that at least the best scenario case should work fine. And another thing which we have in our roadmap, and I don't know how we'll get to this, was the master build, the scaling up robust signature during master build. That is something which has happened in the past. It was annoying for a few days. There are high chances it will happen again in the future, as much as we will try to avoid it. So finally, a small surprise for all of you who are Fedora packager. If you're a OpenSUSE packager, you're probably less interested in this one, and you've stayed so far. So with multi-builds, we have introduced on-demand site tags. So you can create your site tag whenever you want. Well, they work for rawhide, but they don't work only for rawhide, which means you can create a site tag for a stable release branch, which means Fed package chain build, which was only a rawhide feature, now works in stable Fedora releases as well. You can create your site tags for F30 and chain build 100 builds in there and crank them into one update in basically 2 commands. So enjoy that. And that's it for me. If you have any question, I'm happy to continue.
Yeah, let's say we want to plug our own CI system inside the workflow and have report on changes. So what would it take to actually just listen to changes from Modi on the message bus and then know how to report to results?
So the question is, how can I plug my own CI system in this workflow? Yeah, there is we are working on standards on how to, there is a very clear defined message from body that says this update is ready to be tested, so you can trigger off. The idea is you trigger off Fedora messaging and you report to Fedora messaging. So there is a defined message from body that triggers, and there is a standard format that is expected for the report. And then there is one small piece of software that basically is the piece which listens to the bus and uploads the results DB that needs to be adjusted. If you follow the defined format, adjusting should be just listen to the new topic and process the message that way. That's all that should be required.
How do we envision the reverse dependency testing? Because if the core package is changed, you have it's not going to scale. You will be wanting to test thousands or.
So the question is, how do we envision reverse dependency testing? There are a few ways to look into that. One of the first things I would do is go look at my friends in green over there in the OBS world, where they actually do rebuild the entire dependency tree upon a change. So that problem has been solved for them, which means that shouldn't be a problem to solve it for us. There are a few alternatives there. Clouds would be one way to scale up resources when we suddenly rebuild GCC and need to rebuild the entire, most of Fedora. Because the interesting piece about that is we do mass rebuilds currently, and that goes through all the 20,000 packages. But the 20,000 packages don't need to be rebuilt for a new GCC update. All the Perl and Python and PHP modules, which are not C plugins, they don't care about the new GCC. So if we were to do reverse dependency testing and rebuild for a new GCC, we would actually rebuild less than we do today with mass rebuilds, because we would only rebuild what depends on GCC. All the no Arch package here we would ignore. No Node.js packages don't need to be rebuilt.
And what about the feedback from the reverse dependency testing? You want to notify the Python RPM manager that you already the reverse dependency broken?
So the question is, what about the feedback? If I rebuild GCC, do I really want to know the test result about 8,000 packages? Those are good questions, and we really need to figure out what's the answer for this. The first approach may very well be, well, rebuild GCC, you have for 8,000 notifications about things not working. Or maybe, we'll say, not 8,000, but maybe we can group them and you get 8,000 in one email. One way we would do that, one way which would help maybe is also looking into we said we wanted to optimize the test results when we come to groups of builds. So instead of having one build, one result, one build, having one result for the entire group, that will solve that, because then you have a group of 8,000 packages, but you only get one feedback that says all of these packages have failed, but it's one action and not 8,000 actions. So that may be it. Those are, clues or ideas. They are not anywhere defined, or I'm not going to put my hand on the table and have it say this is the way it's going to be. There was something.
So the other problem is the install, upgrade, removal tests. So Debian has had them for years, right?
Mm-hmm.
So what needs to happen for us to have also?
The question is, what do we need to do to actually have the install, update, and upgrades test? I'll say this is a chicken egg problem. As long as we didn't have a gating mechanism, we could build all the tests we wanted. If they had no impact, nobody cares. A broken test that doesn't work on the side there and does not impact me, I can live with a small red dot on the side of my testing bar and in body updates if it doesn't impact me in any way. We had that for years. Taskcontrol has been running and looking into upgrade tests for a long time, and they were not blocking in any way. They had no impact in any way. So there is a chicken egg problem. As long as we did not have gating, there was no incentive to actually go and look at these tests and try to fix them. Now that we have this, I think it's time to look more into that problem. The question is going to be a lot on the ordering. Which one should we start with? I know RPM spec is being worked on at the moment. It's also going to be probably one of the first distro level testing that is enabled. And it's also used as a playground. Okay, how do we plug in a new CI system? Because it's going to have its own pipeline, it's going to trigger it differently. So how do we expand our testing system there? So this one is probably going to be the first one and the next one. After that, it's a good question. Fixing upgrades versus impact on compose. Reverse dependency versus install. Which one should we start with? I don't know. And that's the place where Alexandra is not there, but Alexandra Fedorova, who works on the CI SIG, is looking into this question, so she will be the person to contact if you're interested to help or provide feedback on some of these ideas.
Tiny side question is, how do you count the Fedora packages? Because you said 20,000, and when you go in different tools, the numbers are changing all the way, and now we have modules and stuff. And how do we measure if the number of the Fedora package is improving over time or decreasing? And because we are splitting everything, and it's difficult to have just an idea about what is the key number that we should remember, and is it improving or decreasing?
So the question is, how do we know, where do we get the information about the number of packages present in Fedora? There are two places. The first one is to look into this Git, which is going to tell you the number of Git repos that we have. And that's about over 20,000 Git repos that we have. And you can look per namespace, or you can look only the RPM namespace, and I will give you only the RPMs one, ignoring the modules, the containers, the flatpaks, and everything. The second one, we can monitor, but there's a problem with that number, is that we keep Git repositories also for packages that are no longer shipped. They are retired from Fedora. But we still have the Git repos because that's part of our history as a distribution. So that number is a bit squeezed. You get all the packages that Fedora has ever had. Whether they are active or not, that's a different, you won't get that information there. Well, you could, but that means going through each and every package and checking if they are flagged as retired. The one place where you would have the actual number, and that's you will have to query for it and look for it. That's called the PDC, and that's a database. PDC stands for Product Definition Center, and it's a database, and that's a place where we record for every packages their status, and basically if you are allowed to push to the master branch or not. So if the master branch you cannot push to it, basically means the package has been retired. So that's the place where you will be able to say, well, give me for all packages the status of the status of each branch or the master branch, and from that number you would be able to see how it's going. The last place where you could see progress is going to be Body, but Body works with binary RPMs. So one source RPM can give you, how many sub-packages do we have in LaTeX again?
I think it's up to 9,300.
Something like that, so way too much. So yeah, the body's number is going to be squeezed because it's only going to count the binary RPM and not the source RPM. I think PDC is going to be your closest bet, and that's not going to be the easiest one. PackageDB used to have a feature where it would give you the number of package per branch, but we no longer have that graph.
It's the same for long packs. We take the translation out of LibreOffice and we make one package for each language. We make the installation lower, the footprint of the installation lower for languages don't need translation in another language. So the number we have to count is the source RPM and the end result.
So the remark was it's the same for LangPack, where we have one source RPM that splits a number of RPM per languages, so that you can reduce the install surface on containers and the like. And therefore, that's why the number to look at is the number of source RPM and not the number of RPMs produced. You also had a question, I believe. Anything else?
Is it only for x86 architectures or also for ARM?
The question is it only for x86 architecture or only for ARM? The mechanism is arch independent. The problem is the CI system currently works only on x86 architecture. There is plan to add support for ARM to the CI system, but as far as I know, it's not there yet. But yeah, the idea is to start with, if we can get 80% of the bugs with x86 architecture, it's still better than the 0 we have now. And then when we get to 90% adding harm, then we get another 10%. But it's always 20% of the work is going to get you 80% of the benefits, and the 20 remaining percent is going to take you the 80% of the work. So using this rule, we start with the easy one, trying to get the most results, and then seeing if we can improve that later on.